Okay, so what I want to talk about next is some special logarithms. All right, sometimes we use very special bases. It's very commonly done that we use base 10. Right, that b becomes 10. And when we use base 10, we just call that log. Almost always, if someone writes log without a base, what they mean is base 10. It's just like when someone writes this symbol, what they mean is the square root. Right? They don't write the 2, but that's what they mean. It's just so commonly used that we just, get rid of the number so we can write it down quicker. Same thing's happening here. So commonly used log base 10 that we just don't bother writing the 10 anymore. Okay, so let's look at some examples here. Well, remember the implied base here is a 10. Right? So I'm thinking, what's the exponent on 10 that gives 100? In other words, 10 to the what equals 100? Well, I know that 10 squared gives 100, so this guy is equal to 2. What about log of 1,000? What's the exponent on 10 that gives 1,000? I'm going to let you think about that one a little bit. Why don't you pause the video, see if you can figure these two out. You should have gotten 3 here. 10 cubed gives you 1,000. And you should have gotten 4 here. 10 to the 4th equals 10,000. Now what about these guys? Well, we actually did this one earlier, right? I wrote the 10 down here, and we said that we're looking for 10 to the what equals 0.1. Well, remember, we realized that was 1 over 10, and so that had to be -1. So what about these two? Go ahead, pause the video, see if you can figure these out. Let's see. 10 to the what equals 0.01. Well, 0.01 is 1 over 100. So I know that 10 squared gives me 100. If I want 1 over 100, it must be 10 to the -2. There we have it. What about this one? Well, we're asking 10 to the what equals 0.001. Well, that's 1,000th. 10 to the what gives me 1,000. That's 10 to the 3. But I want 1 over 1,000, so that must be -3. And this log is used in many applications. If you've ever heard about the Richter scale to measure earthquakes, the magnitude of earthquakes, those are logarithms. A magnitude 7 earthquake is 10 times more powerful than a magnitude 6 earthquake. And a magnitude 6 earthquake is 10 times more powerful than a magnitude 5 earthquake. The Richter magnitudes are actually logarithms, log base 10. It's also used when we measure pH, and that is how acidic something is. The lower the pH, the more acidic it is. So if you look at a pH of 6 compared to a pH of 7, right? The 7 is 10 times, actually I should say, since acidic is actually going down, basic is the opposite of acidic, so basic's going up. So a pH of 7 is 10 times more basic than a pH of 6. And a pH of 6 is 10 times more basic than a pH of 5. And the pH is the H stands for hydrogen. It's the concentration of hydrogen ions in the solution. And that's what makes something acidic or basic. All right. So finally, I want to talk about one other special logarithm, and that is log base E, and that's called the natural logarithm. The natural logarithm, they call it natural because it kind of pops up in a very natural way, kind of like pi pops up when you measure the area of a circle, the circumference of a circle. It's just there. It just happens. And so it's a very natural number. It just happens. You don't need to make it up. Like degrees, you make it up. You just divide the circle into, we decided, 360 parts. There was nothing natural about it. But pi is very natural, right? Same thing happens. The number e in mathematics just comes up very naturally. And so when we take a log base e, that's called the natural logarithm. So remember, this number e is the number 2.71828 ... It goes on forever without repeating. It's an irrational number like pi. And it's a very commonly seen number in mathematics. It comes up in a lot of natural scenarios. We saw it when we talked about continuously compounded interest. It came up there, for instance. And so because of that, we like to give it a special name. So we don't have to write log base e all the time. We just write ln. Right? So ln means log base e. So what would ln of these values be? All right? What's log of e? The natural logarithm of e. Well, remember, this is log base e. Right? So this is asking e to the what equals e. Well, anything raised to the 1 power is itself, so that must be 1. Okay, what about natural log of e squared? E to the what equals e squared? Well, it's kind of obvious, right? I mean, what does this number have to be so that this looks like this? Well, it needs to be a 2, right? E to the what equals e cubed? What does this have to be? A 3. That'll make these the same. See what it's doing? The log is just pulling down the exponent, right? Log of e to the negative 1. E to the what equals e to the negative 1? No, it's negative 1. What about this one? Negative 2. What about this one? Negative 13. What about this one? E to the what equals e to the pi? Pi. How about this one? E to the what number equals 1? Well, take a positive number. If you raise any positive number to 0, you get 1. That's always true, no matter, even if this wasn't an e. So this is always going to be a 0. Even if this wasn't log base e, that would have been 0. Let's do another one. Let's do log of 1 over e to the 5th. E to the what equals 1 over e to the 5th. Pause the video, see if you can figure this one out. Okay, welcome back. Well, I'm going to write this a different way, just like we did with some of our previous examples. Remember when I had 0.1, I read it as 1/10. Well, you can do similar tricks here. You can write this with a negative exponent here, e to the negative 5. And now I see the question mark needs to be negative 5. Natural logarithms. So this is how logs work. So we talked about logs in general, and we have these two special logs, log base 10 and the natural logarithm.